Okay, we're winding down on chapter 10, and we want to look at equations of circles using the equations that we have for the conic sections. Once again, remember that the conic sections are the shapes that are formed when a plane intersects a cone. And those conic sections that we study are the parabola. Remember, that's the graph of a quadratic. The hyperbola, which I think is the very easiest one. So I think you've got the hard one and the easy one right there. But we want to look at the circle, and because so many people confuse the circle and the ellipse, we're going to look at both of them. But we're going to start off by talking about the circle, and I'll probably talk about the ellipse in another video, so this one won't be so incredibly long. You need to remember, and I know you had this in Algebra 2 last year, I want you to remember the equation of a circle in standard form as we begin. Okay? Now, an equation, when we graph something, all the points on the graph, when plugged into the equation, give us true statements. So we have a picture of the correct answers, if you want to look at it that way. So when I look at my equation of my circle in standard form, remember that the minus sign is in the formula. Now on this, when I peel off the H and the K, and the H and the K have to come from behind a minus sign, the center of my circle is at the point HK on a graph. And then from that center, I have a radius of R. So once I have my circle, it's very easy to graph. All right, now let's look at some information that we're given and see how we can find our equation of our circle and even graph that circle. So as an example, let me change colors here. Let's look at yellow here. As an example, let's say that the center of our circle is at the point 1, -8, and the radius of our circle is 7 units. Now I want to find the equation of this circle, and then I'm going to graph it as well. So as I find my equation, remember that we're going to use our standard form up here. So we're going to have our x minus h squared plus the y minus k squared equals r squared. Now let's plug in. In the center, remember that the first entry is the h, the second entry is the k, and my radius is the r. So let's just plug in. X minus the h is 1. Y minus the k is -8. And the r is 7. We can clean this up a bit by getting rid of that double negative. So this is the equation in general form or standard form of a circle that has as its center the point 1, -8, and its radius is 7 units. Now we would graph that there's our y. Whoops, my goodness. And here's my x. Okay, so here's my coordinate plane. My center would be at 1, -8 for this particular problem. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. So over 1 down 8. Here's my center point. I like to mark it with C. That's just my habit. I've never seen that done, anywhere else, so it's just my habit. And then from there, what I want to do is, since I know the radius is the distance from the center of a circle out to the edge of the circle, I'm going to count from the center up 7, so 1, 2, 3, 4, 5, 7 units, and I'm going to go to the left 7 units, and to the right I'd count 7 units, and down below I'd count 7 units, which puts me off the chart with this one. Then I would just sketch out my circle. Okay. At any point, any ordered pair, anywhere on this circle, if I plug that X and Y in over here, I get a true statement. Let's look at another one. Okay? What if our center is now at the origin? Remember what the origin is? It's the point 0, 0. And our radius is the square root of 10. Okay? Now, as I see here, you've got, this is my H, this is my K, this is my R. So let's just plug in X minus H squared plus Y minus K squared equals the radius squared. And we can clean this one up significantly. We can drop the 0. X squared plus Y squared equals 10. Anytime you just have the X squared plus the Y squared, you know your center is going to be at 0, 0. To graph this one, I would put my center at 0, 0. There's my center. Then I would go to my calculator and get an approximation for the square root of 10. Okay, and that's going to be approximately 3 point something, just a little over 3. So as I start to sketch out a graph, I would have to kind of estimate a little above 3 and just kind of, make my circle a little estimation. Okay? Any point on that circle, if I plug it in to this equation, I get a true statement. All right, using the same concepts with the circle, let's see what else we can do with that circle. Let's say that we need to write the equation of a circle. So we're going to write the equation. We know that form now that has to be memorized. Each conic has its own equation. Write the equation of a circle with center at -3, -2. And the circle passes through. In other words, one of the X and Y's that make it true is 1, -2. So we've got to come up with the equation of that circle. Now let's see what we've got so far. We know that the standard form is that X minus H squared plus Y minus K squared equals R squared, where we have to plug in an H, a K, and an R. Well, look at what we've got so far. We've got the H and the K. So -3. Again, remember that the minus is in the formula. So really all that we're missing is the R. Let's clean this up. Get those signs in the best mathematical form. So really all we need is R. Well, how can we find the r? They've given us an x and a y that works. We know that the circle goes through. It's one of those points that make the equation true. So let's use that information over here, and let's plug in and see if we can't solve for our r. When x is 1, y is -2. And you see, we just have an arithmetic problem here to solve for what our radius is. Well, really, we just want our radius squared, don't we? Let's see what happens. 1 plus 3 is 4, so 4 squared plus 0 squared. So 16 is r squared, and since r squared is what I'm going to be plugging in, let's just bring that 16 over here. The equation that I'm looking for is that pretty guy right there. So by plugging in the HK as well as the XY, we were able to find the R. But in the final equation, I want my X and Y to remain generic for the other points that are possible to make the equation true. Let's look at another one like that. I think maybe 2 examples would be a good idea. Same directions, but this time our center is going to be at the point -2, 4, and a point that's on the circle, or the point that the circle passes through, is going to be -6, 7. So once again, as we plug in x minus our h, remember this is h and k because it's the center, squared plus y minus the k squared equals r squared. And this is an x and a y that make our statement true. So I can plug in -6, and I can plug in the 7, and let's see what r squared is going to be. -6 plus 2 is -4. -4 squared is 16. And then 7 minus 4 is 3. 3 squared is 9. So our r squared is going to be 25. So to complete go back and put the x and y in, I'm going to have x plus 2 squared plus y minus 4 squared equals 25. This is the equation of my circle that passes through -6, 7, but has as its center -2, 4. There are other situations that we're going to face that we're going to need to have to manipulate and do some mathematically correct and mathematically sound operations to come up with an equation of our circle. So let's say that we're given that the equation of our circle is x squared plus y squared minus 8x plus 2y equals -8. Now remember, guys, that we are always keeping in the back of our mind this idea that our equation of our circle has to look like this. That's the standard equation. So we've got to always, whatever we're given, we have to make it look like this guy. Well, you see how you've got some parentheses that are squared in there? Those parentheses are squared because you had a perfect square trinomial that factored beautifully. Remember that from Algebra 2. So what I'm going to do over here, I'm going to come up with some perfect square trinomials legally so that I can factor my little circle in a pretty way. So I'm going to have to go through the process of completing the square. Alrighty, so when we complete the square, we get our x's together the best we can and our y's together, and then we want our constant number to be over on the right of the equal sign by itself. Now, I'm going to complete this square first so that I can factor it into something that looks like that. To do this, you take the coefficient of your linear term. That means the number multiplied by the x to the first power. Okay? Take the coefficient of the linear term. Okay? So in this case, for my x, that's the 8. So I'm going to take the 8, and I take half of it. Then after I take half of it, I square what I get. So the 16 is the number I'm looking for. So I'm going to add 16 to the left of the equation, which means I must add it to the right of the equation. Now I can factor x squared minus 8x plus 16 into x minus 4 squared. And I've got that dream that I was thinking about up there. I've got the x part ready. Okay, plus. Now let's look at what we've got to do for our y. We've got to complete the square for the y, so we can put it in this pretty form. Okay, so I'm going to take the linear term of the y's, and that's going to be our 2, because the 2 is the coefficient of the y to the first power. So I take whatever that coefficient is, and I divide it by 2. And then whatever I get, I square that answer. So I'm going to get 1 this time. I'll add a 1 to the left, but that means I have to add a 1 to the right. Now I'm ready to factor my y's because I have a perfect square trinomial. So when I factor, I'm going to get y plus 1 squared, and then over here on the right-hand side, I just do my arithmetic. Negative 8 plus 16 is 8. 8 plus 1 is 9. So here I have a circle with its center at 4, negative 1, and its radius at 3. So we took information that we were given, and by completing the square, we found the equation of the circle. Let's do another one by completing the square together. Okay, so if you need to stop and write this down or whatever, that's fine. But I'm going to go ahead and move it up and start a new problem. Okay, so this time we are given that our equation is x squared plus y squared plus 8x minus 14y plus 40. We're told that's a circle, but we want the standard form. So we're going to put our x's together, and we're going to put our y's together, and then the constant number has to be taken legally by subtracting from both sides to the other side. Okay, now we're going to go through the process of completing the square. My linear term is 8. Half of 8 is 4. 4 squared is 16. So I add 16 to the left. I add 16 to the right. Now my x factors into it is a perfect square trinomial, so it factors down pretty. Now let's look at the y. My linear term for my y is 14, so I'm going to take my 14, divide it by 2, that's 7. 7 squared is 49. So I'm going to add a 49. Whoops, I'm sorry, 49 up here and a 49 over here. So I want this off here so I can factor. So I've got a perfect square trinomial now. That's going to factor. And And then over here, the negative 40 plus 49 gives me 9. That gives me a 25. So I have a circle with a center at negative 4, 7, and a radius of 5. One more little example that's not very difficult at all, but let's see what happens with this. If I want to put this in my standard form, and I subtract, or add rather, the 4 to each side, here I've really got my standard form. But if I want to take it a step further, I can say this is really what I'm looking at. So I don't really have to do any completing the square. These are standard form. Either one is okay, because I can see that my center is at 0, 0, and my radius is at 2. There's just one more thing that I want to talk about with intersections of circles. We want to talk about how do you find the ordered pairs of a circle that's intersected by a line or a parabola or a segment or some other type of shape. We're going to specifically look at what happens if a circle is intersected by a line. So our problem that we're given is that we're to find the point or points of intersection, find the point or the points of intersection, that means the x and y, to make our point of intersection between the circle, it's the one we just talked about, isn't it, and the line y equals x. Okay? Now, this is a system of equations because we're looking for the intersection of two graphs. So really, this is a system of equations. When you have a system of equations and they're not linear, you're going to use here the substitution method. To solve these. So what I'm going to do, I'm either going to replace the first y with x, since I know that they're the same, and solve, or I'm going to replace the the x with y, since they're the same, and solve. So you've got a choice there. It's whichever one appeals to you. I'm going to do the first one. Simply because I'm in the habit of solving for x, and I imagine a lot of you are too. So I'll get 2x squared equals 4. Divide each side by 2. So my x values are plus or minus square root of 2. Now, we've been used to checking those to see if we need to throw out a negative for a negative measure, but that's not what I'm looking for here. I'm looking for ordered pairs here. So I'm not going to throw away my negative at all. It's important to me. This would be a point where I think it would be a good idea for us to draw the picture, and let's see what that picture is looking like. So I think to make this neater, I'll draw the circle first. So I'm going to get my little circle here. Okay, now let's put it on an axis. I may be drawing this a little bit differently than you're used to. Kind of out of sync, but I'm doing that because I know that it's going to be easier this way for us. Okay. Okay, so the center of my circle is in here at 0, 0. Woohoo! Didn't want to do that. Is in here at 0, 0. Okay, I know that because this is actually x minus 0 squared. Remember what we did a while ago? And I know my radius is 2. So I've got 1, 2, 1, 2, 1, 2. 2. So my radius is 2, which is the square root of 4. So there's the circle that we're talking about. Now, our line y equals x. Let me add a few more points here, just for good measure. Okay, our line y equals x is going to go through it. You have 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. It's going to go through this situation. So let me get my line up here. And we will put a line through there. Okay, so here's a picture now of what we're doing. So what are we looking for? We're looking for this ordered pair and this ordered pair. The points that the line and the circle, and that's not going to be the inside of the circle, we're talking about the circumference of the circle. The 2 points that they intersect or have points in common. We've already figured out the x's, so a plus radical 2 and a minus radical 2 are our x's. Now, just like we would if we had a linear system, we're going to take what we found x to be and plug it into one of the original equations of our system to find out what the y's would be. Well, don't you see that this would be absolutely positively the easiest one for us to look at? This tells us that y and x are the same thing. So if my x is radical 2, my y must be radical 2. If my x is negative radical 2, my y is negative radical 2. So the points of intersection that we were asked to find are going to be the point radical 2, and the point negative radical 2. So that's how I would find the intersection of a circle and a line. Why don't we look at one more of those? So if you want to stop and study this for a minute, that's great. But I think we'll do one more of these just to make us feel a little bit better. Okay? So now I'm going to raise this up. No, I'm not. That's going to be too messy. So I'm going to change pages here. Let me change pages and we'll pick up. All right, so let's get another example here so that we can graph here and find the intersection. So we want to find the points of intersection, pointer points, because if we had a tangent to the circle, we'd only have one point, wouldn't we? We're going to find the point or points of intersection between our circle is going to be x squared plus y squared equals 8. And our line, this time we're going to have y equals negative x. So whatever our y turns out to be, the x is going to be the opposite. Okay, now I told you a while ago we're going to always use a system of equations and the substitution method. So we either replace the y with negative x or we replace the x with negative y. It doesn't matter which one. I think I'm going to replace the y since it's the one that's solved for. So for y, I'm going to put in negative x. So that's going to give me x squared plus negative 1 squared is 1. And I'm going to have 2x squared equal 8, or x squared equals 4. So x is a plus or a minus 2. Okay, can we get these answers without drawing the picture? Let's see if we can. We know this line is going to go through our circle. So our x's are plus 2 and minus 2. But you see how the x's, whatever your x is, you take the opposite of it to get your y. So the opposite of 2 is negative 2. The opposite of negative 2 is positive 2. So if we were to draw our circle and put our line through it, we would see that these are the 2 points where that line intersects or shares points or have points in common with our circle.